The first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people are evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spend a lot of time making sure the accurate information gets out.
This is live. Still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family member was being evacuated, a group would just jump in and help out. So it was huge. They were watching out for each other.
Hello everybody, thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
Aloha everybody, I'm geologist Philip Ong, here with Mr. Dane DuPont, HawaiiTracker.com, bringing you guys another Hawaiian Volcano Tracker update. Today is Thursday, March 16th, 2023. How you doing today, Dane?
Doing pretty good. How about you?
Doing alright. It's dried up on island here. It's blazing hot even up here at 3,000 feet elevation. I can't imagine what it's like. Oh, you guys
It's
down in
summer.
the lower levels.
Yeah, it's just summer all of a sudden. Just
Yeah.
transitioned in a week.
Yeah, all that cold air came through, dumped a bunch of snow, then moved out. Now it's muggy and sweaty. Yeah, man.
Yeah. Yeah.
Oh.
Well, some interesting things on the volcanoes, or at least on one.
Yeah, actually, both volcanoes have news this week. The Mauna Loa news
Yeah.
is that USGS downgraded its alert level, right? We'll talk about that briefly. But on Kilauea, a small intrusion reported. And the other agenda item today is documenting the USGS actually for the first time landing by helicopter on that central island in the middle of that crusted over lava lake. So that's pretty exciting. We've discussed that in the past, that possibility. They found conditions were just right, and they went and did it. So we'll share that with you guys too.
Yeah, that's pretty cool right there, being able to actually get in there and land something on that. I mean, we've talked about it for so long, and now to see it actually happen. I mean, the thing is, it's a huge landing area now, so it's different than when it was before.
Well, so if you're trying to land on the actual island itself, that area has actually been shrinking, right? So in some ways, you might think they're kind of making sure that they take the chance before that whole thing gets buried. Another eruption comes, I think it might be totally gone, and you lose your chance to sample it. But we'll get into all that here in a bit. First, we'll talk about the monitoring on Kilauea. As usual, we'll take questions. Dana will be leading discussion in the chat, collecting some questions for us to discuss here along the way. And anything else, Dana, before we get into our summary here?
No, I think that's about it. We did go to that USGS event last night, but yeah, let's get into it, and we'll talk a little bit more later.
All right, sounds good. So, this week's Hawaiian Volcano summary. We're showing here Kilauea in the daytime over the past week, and you can see lots of fume coming from the crater floor, but there's been no active lava. In fact, I've cut out the nighttime shots because there's not a whole lot to see from this angle. There is a little bit of glow still visible from little cracks on the crater floor, but for the most part, activity is still paused. However, this past week, on March 11th, there was a small swarm of earthquakes here underneath Kilauea summit. And there is the largest mapped extent of any map that you can find online. This is from the USGS website, showing all the very small events underneath the southern and western edge of the summit near the lava lake, and also looks like a little bit trailing off into that upper southwest rift connector, possibly, if this is reliable here. However, if we look at the tilt signals, this is a tilt signal from 2 days that is back covering that period of time. This little blip right here is the tilt deviation that occurred at the beginning of that earthquake swarm. And you can see that there was no offset that occurred as a result of that, and really the volcano resumed its regular deflation-inflation pattern afterwards. So zooming out, here is a tilt for the whole last month. And here is that intrusion event, that little wiggle right there. But you see it's in the middle of these deflation-inflation cycles still ongoing now that were happening before. All this follows this pattern of not quite a month ago, that large deflation that ended the eruption, or paused the eruption, and deflation and inflation continued for the whole rest of the remaining weeks here. And here we have this large inflation that was starting at the beginning of last week's update. And it seems like that was the manifestation of the magma pressurizing and then causing a little intrusion here. But the long-term prognosis doesn't look a whole lot different, really, because it didn't change a whole lot as far as the surface tilt is concerned here. So magma is still coming to the volcano, it's still pressurizing underground, and so it's just a matter of time to see what it will do next. And you can tune into our full update if you want to hear all the details of that. However, just to finish off our summary here, Mauna Loa has been downgraded today from advisory or yellow alert codes to normal and green on the 16th here. It's been 3 full months since the end of the Mauna Loa eruption, and it ended back in December 2022. So this is all business as usual. USGS has defined in the past this 3-month window to call an eruption over. We've passed that, and so it's all good on Mauna Loa. Mauna Loa is still inflating, but it's really lacking in the earthquakes that would suggest that it's pressurizing to build to another outburst. So it's doing its normal thing. It is filling with magma. It's alive still, but no sign of imminent eruption on Mauna Loa, and thus the downgrading to green as expected. So that's the summary this week. We can get into some of the details here with starting with Kilauea. Let me first put up the visuals on Kilauea that we have, and I'm going to focus on the visuals, leaving out the landing part on the island here first, and we'll come to that here a little bit later. It's just kind of keep it a little bit more coherent. So we'll start off with a little bit more expanded view from this KW camera. I showed you guys just a daytime views. This is day and nighttime for the last week here. So you can see at the beginning that last little pad of lava that was disappearing in there, and you might see a couple spots of glow from that west vent area and down in here, and maybe not if I don't blow it up because it's really only a few pixels on this big frame here. But I can see a couple little spots there, nothing really major. We'll see a better view when we have the V1 camera coming up here next. But just so you can see what it looks like day and night the whole past week, we'll document this pattern, right? A lot clearer. You see the fume blowing elsewhere. The volcano is still putting out low levels of gas, not as much as when it's erupting, putting lava on the surface, but still enough to affect communities, and we'll talk about that as well. Switching to the V1 camera, here it is from last week. You see a couple of spots of glow here. We're zoomed into this western basin here. You see the nighttime views, you see a couple of these flashing glows of areas in the crack, especially back here, right? But the camera ends up being zoomed out here in 11th. There is a day of rain that comes through there. So another day there, and then it zooms out again. They've moved the camera a little bit. So now we have a little bit of a wider view here of the caldera floor. Presumably because if activity does resume, it could pop up potentially anywhere on this crusted crater floor here, right? Potentially even on the outside edges along that downdrop block or these crater walls on the side if it were to break a new path to the surface. On the F1 camera, the thermal camera, we see that last remnant of that overturning lava that we saw at the end of last week, and some glow from this west vent complex here. But not really a whole lot else, really. It's just quiet. You do see some flashing when the rain comes through. You do see it put out these weird colors. I didn't clean it this week. It was not too bad, just to show you guys what it looks like normally before we pull out that jittery flashing stuff. When it's really raining, it gets really psychedelic and it's hard to even watch. But I think you guys got the idea there. Not a whole lot to see or even to replay. You really see those spots of glow. A little bit around a perimeter here too, where we've had ooze-up flows in the past, but just glowing cracks visible in a thermal and not actually putting out lava onto the crater floor. One last visual for this part is a tweet from @AR_ETSCH. It's pulling out Sentinel Copernicus imagery and a clear view from space of Kilauea summit here. There it is, only a couple clouds on that Mauna Loa flank. And I'll just advance here to this next more zoomed in image. Assuming it responds for me here. Come on. There it is. So there's that zoomed in view. You see that downdrop block is this area right around here. Oh, whoops, looks like my computer is not quite keeping up. All right, so here is that downdrop block area right there within a larger caldera, which is off the screen like that, more or less. And within that is the crusted lava lake, which is right in through here. So that's the image there. I thought this was kind of cool. When I looked into here, I saw a little bit of a face, a little bit of a skull almost. I don't know if anyone else can see that, but just for the curiosity of it here. Clear view, kind of accentuated by the deposits of minerals from the steam vents that make that whitish layer on the crater floor there. So that's what I'm seeing there. That head right through there, a couple eyes, nose, mouth right in there. All right, moving on from those observations, we'll talk about the gas a little bit. You can see that there is still gas coming out. So let's first go to our purple air, current conditions. Everything is fairly in the green here. There is, you see one spot here in Volcano that is up at 68, so a little bit of spotty VOG areas depending on the wind directions and exactly the time of day. I'll show you the forecast for the VOG from the VOG mapping project here. There's this plane here, so here it is. There's not a whole lot of gas coming out, but you see the wind is dispersing it towards the saddle region between Mauna Loa and Mauna Kea here, and also locally to the volcano area right through here. And this is also showing a little bit of remnant amounts here in South Kona. I'm not sure where that's coming from exactly, but that's the VMAP forecast from University of Hawaii for the next couple of days here. And so even at low levels, it can still cause a nuisance. And just to show that a little bit further, here is the air quality meters from a national park. And for the most part, everything is green, but you can see, for example, here is a plot of Volcano Arts Center SO2 today, and you see that early this morning around 5 a.m. it did spike to the orange and to the yellow, back down to the yellow, and then back to green the rest of the time. So it can be locally foggy in areas, especially nearby the summit here. Otherwise, everything at National Park is in the green. And the winds are fairly slack, so if I pull it back to the summary map view here, we get this little circle showing not really strong winds blowing everything off in one direction, but it can kind of waft locally to anywhere in an area. So that is the air quality, the gas here. Gas does remain our main hazard for the eruption. So this is our hazard summary, just showing where that hazard might be, is just where the wind can blow it, and those low levels can still be a nuisance and problem for locals in the immediate area here. Okay, so moving on to lava viewing. Now, obviously there's no lava on the surface quite right now. So the National Park has changed their eruption viewing site to a webpage to a 2023 Summit Eruption recap here. A nice image from Michael Newman here of that first night of the eruption. And you see it kind of reviews that, shows all that map. There's images of the fountain, but essentially this is almost like an archive now, awaiting what happens in a volcano next. So not advertising there's lava to see, seeing as that is not what you'd expect at the moment. However, the viewing areas for the eruption area here are the Kupina Ipali near the Volcano House and Main Visitor Center, the entrance station here, Wikahuna Kilauea Overlook on the north side of the caldera, and Kanakakoi in the south. The only reason I point this out is because we're not sure how long it'll take for the eruption to actually resume, but when it does resume, that's the time to come up and get the best view from any of these areas. And that first few hours to the first day of that eruption is usually the most spectacular, the most coverage, the biggest outflow, biggest volumes, and all of that. And just to recap, and since there's no other lava to see today, I just thought I'd throw in the clip from the beginning of this last eruption here, at the beginning of January, where we had these big fountains. This is sped up here, and these big surges and waves of lava sweeping across the crater floor. This is an example of the kind of thing that was only visible on that very, very first day of this eruption, and point that out in the viewing areas, just in case that happens to resume within the next week before we can come back to you guys and point out some signals of that actually happening. At present, we don't see any current immediate buildup, but that could come on fairly quick, and that's the lava viewing outlook, right, for this week. Not any lava to view right now, but areas to prepare to go to for the next startup here, whenever that may be. So moving on to our earthquakes. Let's get to earthquakes here. And actually, I'll put up the information statements from the USGS first, because a large part, I'd say the most convincing part of this intrusionary event, were the earthquakes themselves. So this whole sequence began from the USGS with an alert on Saturday at 11:26 a.m. And they note, a shallow earthquake swarm has been detected beneath the summit of Kīlauea volcano, accompanied by significant surface tilt excursion. Resumption of eruptive activity at Kilauea summit is likely imminent. And that was really it, short and sweet. That afternoon, however, by not quite 6 p.m. here, they write it's not erupting. Signals recorded by the USGS HVO indicated that a magmatic intrusion occurred beneath the summit of Kilauea between approximately 11 a.m. and 12 p.m. on March 11th, so it only lasted an hour. As of 5:30 p.m., seismicity has returned to background levels, ground deformation has stabilized, and no lava has been observed at the surface. Resumption of eruptive activity at Kilauea summit no longer appears to be imminent, although it is possible that another intrusion or resumption may occur in the near future with little to no warning. So that's the prognosis there, and kind of recapping in more detail the information here. The shallow earthquake swarm was detected between 10:30 and 11 a.m. The swarm was followed by magnitude 3.4 earthquake located 4 kilometers southwest of Volcano, Hawaii, at a depth of approximately 1 kilometers, 0.6 miles, at 11:50 a.m. This earthquake was felt locally and triggered a rockfall near Uealoha, aka Byron Ledge, in Hawaii Volcanoes National Park. Seismicity diminished at 12 p.m. This has since returned to background levels. Then a note that the tilt meters have been recording an inflationary signal at the summit since March 7th, indicating magma has been accumulating beneath the surface. Tilt excursions also coincided with this morning's earthquake swarm. Summit tilt has stabilized since approximately 12 p.m., although slow inflation continues. The pause began approximately 5 days ago, and Kilauea remains at watch/orange. No unusual activity in the East Rift Zone or Southwest Rift Zone. Monitoring continues. That was the next update, and the one the day afterwards is pretty similar. It does add a couple little changes here. So it does expand a little bit here. No significant changes along either rift zones. Yesterday, increased rates of seismicity and deformation at the summit suggested the eruption was about to resume. However, rates of seismicity and deformation later diminished and magma did not reach the surface, resulting in an intrusion instead of an eruption. Right? So that's kind of why we sometimes call these intrusions failed eruptions. Many of the same processes, it's just a matter of whether it breaks to the surface or not. The volcano is still doing all the work to relieve its pressure, and it can do that without actually reaching the surface. That's when you get the intrusion instead of eruption here. Resumption of eruptive activity at Kilauea summit no longer appears to be imminent, although it is possible that another intrusion or resumption may occur in the near future with little to no warning. No active lava, tilt meters, switching from inflation to deflation. Let's see here in a swarm. That's all the same information there. No unusual activity in either rift zone, and no SO2 there for either as well. So that's the summary of the alerts. If we look at the actual earthquakes map here, here is the main USGS one, and here is the plot of events. Right, so you can see they're largely underneath the summit area. You get a couple events. Here's one off to the southwest here, and one down in a Kilauea fault zone down in here, a little bit further south. But by and large, you don't see the full extent of this, right? I'll just zoom it out so you can see what else is happening on the island, which is our usual Pahala earthquakes, Mauna Loa adjustment ongoing still, but otherwise not a whole lot. Really not a whole lot of earthquakes even there. You can see some of these background events underneath Mauna Kea, Kohala, and west Hawaii. And so for that reason, we will switch over to the USGS 1 week earthquake page, which is the one I showed at the top of the hour here. And zooming into that, you can see here, these are not colored by depth, right? So the orange is the shallowest, I believe, or maybe yellow is the shallowest, and orange below that, and then blue and green below that, right? So these are all fairly shallow in the upper parts of the volcano. And it's showing the bigger events here that are showing up on that previous map, but also showing this little tail into that upper southwest rift connector, which is interesting as well. So not quite clear what's happening there. We'll have to wait to see if there's any signals. Looking at tilt meters and other things in this area, there's nothing obvious happening there, no sign of any deformation on the ground. So it could be that this is an area that's just adjusting as well, right? We know that this was the area of intrusion back in August 2021. So there could still be not fully hardened yet and adjusting to these pressure changes, and for that reason causing small seismicity as well. Not quite clear what's happening there, but that's the fullest pattern of earthquakes we can see here. Otherwise, you see the south flank is still showing its typical background activity, so it's likely still moving, more so in this region here than further east. Here's that lower east rift zone area, middle to lower east rift zone. Not as much background activity there, much more so in this upper east rift connector south of it, and this uppermost rift zone that's upstream of Pu'o'o, we'll call it, right? Upstream, because the rift zone is the pathway of magma from the summit, kind of heading off in that direction. We're not seeing any sign of that here. I'll point that out as well. But if anything, it's filling these areas around the summit, and possibly that southwest rift connector adjusting as well. Looking at the depth here versus time, right? We're looking at these orange events are the shallowest here. So here is that pulse that comes in on March 11th there. And there it is. That's that sequence of shallow seismicity and adjustments. And you can see that since then, time going on here, there's been some background activity still, but not nearly the size and frequency that you saw before. And just to recap, this is plotting everything on the entire map, including the south flank events. So really, it's just showing that distribution of everything. And we'll take the USGS report that really lasted about an hour seismically there. Earthquakes for the last month, plots and earthquakes per day on the left, and this is the last month here on the bottom. So this was the 11th right here. That's that spike in seismicity that we saw. It reached 80 earthquakes in one day, which is not a huge amount by any measure. We've seen way more than that in the past with other intrusions. It's been in the hundreds, approaching 1,000 even. So pretty small seismic footprint here as well. You will notice that before this event occurred, the background seems to be fairly low, right? Largely below 40, 30 earthquakes per day here. And since then, it's remained a little bit on the higher side, more around 50 earthquakes per day or so. And so it's still a little bit elevated above that previous background where really not a whole lot was going on, but it's not really at like alert levels or concerning levels. It's just showing that likely it's still pressurizing. The magma didn't find a way out, so whatever pressure relief occurred was just temporary to that intrusion occurring, and then since then is having to continue working to reduce the pressure that's still building underground as we go. So comparing month earthquakes at the top here to the month tilt on the bottom, there is that signal we pointed out earlier, and you see how it corresponds to that same peak in seismicity right there. Right? So that jump up kind of ramps up earthquakes as well, so suggesting that there was kind of a increase of pressure here. So maybe you had some batch of magma come from that deeper area to the shallower areas and causing this pressure and triggering that small intrusion. But overall, the pattern still remains what we described earlier on, right? That following that large deflation, which paused the eruption back here, the level stayed low, and then it's basically come back up, and now it's stabilized once again. And on top of that, you see superimposed these deflation-inflation events that are just showing overturning within the magma chamber. So it's still convecting in there, even if it's not pushing its way out. Even as it comes in and pressurizes, it's still got gases that are buoyant that want to come up, and it's still got magma that's more buoyant because it's hot and wants to come up, and it can displace the stuff that's been sitting there a little longer and is cooled and degassed a little bit as well. So that's what we imagine these deflation-inflation cycles are actually caused by, but honestly, no one really has nailed it quite yet, right? Still a pretty good guess. And we see that pattern with gas pistoning, and it does all seem to fit together here. So looking at the last week here, there is that signal, which you see didn't really cause any offset. Deflation-inflation events now seem to be back to normal. So earthquakes for the last year are here. So here we are. So now I should point out these are earthquakes per week now for the last year. So that was the week where it was a little high and just right there. And you see this current week that we're in now is coming up to a similar point, but this is nothing like what we saw building up to the eruption here. This is December 2022 to January, and right in here is what that eruption begins in January 5th, 2023. So you see that before that, seismicity was quite a bit higher. We discussed expecting seismicity to build up before we saw another breakout or intrusion or that kind of thing, and we saw a little bit of it here. Maybe suggesting that where it pushed through was an area that was a little bit more susceptible. But we haven't really reached this level of quaking and shaking that you'd expect before any kind of major outburst, right? And that may come in the next week. It may come pretty quickly, or it may build up gradually. We'll have to wait and see. So for the GPS, this is 1 year. Down here, GPS for the 1 year. This is Uikahuna to Crater M, north and south across Kilauea caldera. So this shows that continued expansion. The crater has been growing further apart. The wall has been growing further and further apart over time, even as magma comes into the volcano and erupts up on the surface and fills that crater and overflows and all that. It's still not coming out as much as is coming in below. So the underground area is still bulging, pushing those crater walls further and further outward. And that's the pattern you see for the most part, with a couple little wiggles in between. I'm going to zoom into it here. When eruption began here in January, you see it actually relieved that pressure for a while, plateaued, and then here in mid-February, when we started to see the decrease in activity and that posting events and eventually the shutoff, that's when we started to see the crater walls begin to expand once again, right? Starting to push further and further apart, because once again, no more magma was reaching the surface, so it was building extra underground, and thus pushing the volcano further apart there. Now, interestingly, and this is really hard to tell because it's just the most recent data, and this often gets adjusted a little bit, but it does appear that it did dip down a little bit here at the end, right? And probably maybe won't go that far down. It may just well go back up potentially. Who knows exactly what will happen there, right? But at least a small temporary slacking of that distance between the caldera walls, likely in response to that slight relief in pressure from that intrusion that occurred over the weekend here. So we basically get one data point a day, and it kind of comes in little by little here. So we'll have to wait for time to pass to get more insight on this. And the same is true on our other stations, which we have here as well. This is a 2-year GPS plot, so it's twice as long as the previous one. So the data we're looking for is even further scrunched on the right. We probably can't see the last weekend to now, but I thought we could look a little bit at these patterns around the summit, especially. Here's Uikahuna, right? And this is the northwest part of the caldera. And to recap, or in case no one's seen this before, if you haven't joined us before, these GPS plots are broken down into 3 components. There is an up and down, that's the very bottom, and then east-west and north-south, right? So this one is labeled east, north, up. So if the line is going down, that means it's moving towards the west. And so we zoom into the last month or so here, this very last part, we can see that the northwest part of the caldera has been moving to the west and to the north, more west than north, and at the same time also rising up, right? And you can see that the rates, the actual steepness of this line is significantly different here. So it really was building pressure for the last couple of weeks here. You can see the up signal, and really how much is getting pushed to the west is especially dramatic here. Right? If we go to the eastern side of the caldera at Byron's Ledge, Waialoha, as we mentioned earlier, where the rockfall occurred, the east component you see just skyrockets here in the last couple of weeks. So it was really getting pushed to the east quite a bit. Not so much to the north, it's more on the east side, so all of it's focused on that one component to the east. But if we look at the up signal, it's also been showing a bit of that vertical motion as well, right? It's hard to tell. It seems like it's a little noisy in there, but it certainly appears like there was getting pushed east and up on the east side. And on the west side, it's getting pushed west and up, right? And then a couple more outlets in the southwest. And similarly, you see not so much east and west in that case, but it's actually getting pushed more to the south pretty quick here. So south, not so much up. And over here on the southeast part, quite a bit south, and also, in that case, also rising up, right? So you see how it kind of vary from different quadrants of that caldera area, but certainly that eastern side was feeling a lot of deformation, and so was the western side, although not quite as much there. If you look elsewhere on the East Rift, for example, by Mauna Ulu, you see everything still going down. You see none of that acceleration in signal here. No change in that north-south signal. No change in that east-west signal, right? Same thing further east at Kananui-Ohamo. That's just west of Pu'o'o. Same kind of pattern. Pu'o'o, same kind of pattern. Kamomoa, same kind of pattern. So really, it's just restricted to the summit. There's no sign of anything going into the rift still at this point in time, right? Even further east, Jacuzzi and Jonica, way down on the lower east rift, really showing all standard, unchanging really for the whole last 2 years for the most part here. It's a little more interesting if we look at the south flank. The south flank, just south of the summit at Ahua, is also showing that southern movement, not so much up. And if we go here to Puhimau crater, also south, does show a little bit of that southern acceleration and no up. And Devil's Throat, also showing a southern acceleration. That's all within that Kauai zone. That's like that accordion south of the summit. That is a whole cracked area that adjusts to the rift zones in the summit, all moving independently at times. So that's that northern area. When you go other parts of the south flank, like East Idaho, you don't see that, right? You don't see that at Makapui. You don't see that at Kalapana Trail, which both of those areas are actually still moving back to the north, which is still showing that whole area is still torquing, right? It's still rotating a bit there. So the south flank certainly is a participant in this activity here, especially in that area just south of the summit. Looking elsewhere, I won't go through every plot, but really there's nothing else that you can pull out of any of these other south flank areas. So really it's that localized summit area, and you can see how really when I pull it back to the summit stations here, that's the most dramatic signals you see right there, is that the pushing right around the summit region. So that's as much as we can tell right now. It's interesting. I was wondering how much of this contraction is from this intrusion, or whether there's something else funny going on. And we can see that even though that the sides are getting pushed further apart, they may do so at different rates. And they're both recently going up, and we'll have to wait a little bit longer to get the data in to really analyze the last week or so as it scrolls onto that graph there, since it's all squished together in either a 1 year or 2 year plot here. And to just show a different view, the view we normally look at across the East Rift Zone at Pu'o'o, distance north and south, still going down steadily. That's showing a contraction. That's the simplified summary version we like to look at here. And only once in a while do we dig into that other aspect when we see interesting things, such as here at the summit. So that's how the GPS fits into it here. And now we're not really focusing on earthquakes as much, but all the other monitoring signals. So let's switch our tag here. SO2, we don't really have any new measurements, but we expect the emission rates are similarly low in the hundreds of tons per day rather than in the thousands. This is essentially background levels, which, as we know and mentioned, can still be a nuisance. Our lava depth plot has switched from being not useful because of all this noise from weather events to not even updating in the most recent days here. So nothing we can get out of that once again. And we'll continue here by looking at the tilt, right? So I thought what we could do now is look at some of the historical context of these intrusions. Our intrusion that we've just witnessed here in this 1 month plot, you can see it's got a very weak signal as far as this tilt plot is concerned. So how does this fit into some other patterns? The first thing I thought I would do was, besides just showing the summit tilt, let's bring up the sand hill tilt, which is here. Right? So that same time, the 11th would be right in here. It's hard to see much of anything. I can zoom it in a lot. You do see a little bit of a rise, but no big dramatic step offset, nothing that would indicate an intrusion, something like that, right, that we've seen in the past. It's a little bit deceiving, the scale of this, because if we scroll all the way back to the left here, kind of hidden, there's this green line, that's a big earthquake that jolted the instrument all the way to one side and all the way back to where it started, so there's no offset in that one either, but it did skew our plot, so we're really showing a minus 35 to 10 microradians. It's a really blown up scale, really zoomed out quite a bit. So maybe if we were zoomed in a little more, we'd see that this rise mirrors that inflationary phase of the summit, but we're not really seeing any localized intrusion area here in the southwest. Just to throw that in here for now. We'll come back to this and you'll see why it matters later. But let's go back to 2020, right? And we're going to go back to the end of November, beginning of December 2020, and December 2nd into December 3rd, we had that intrusion which preceded the first eruption at the summit following the 2018 collapse, right there. And you can see in this case, it was at the Wikahuna an offset of, see, we're at minus 10 here and going up to plus 10, so about 20 microradians, maybe 25 microradians, something like that. I think the next slide might, or one of the slides coming up will say how much. So that's what that actually looked like, a much larger offset, right? And if I pull up the earthquakes map from that week, it looked like this. When you zoom it in, you see a whole lot more activity in the summit. You do see both those stringers into that upper southwest rift connector, and also you saw it into the upper southeast rift connector back in that phase, right? That was the last time we really saw the southeast rift connector be activated as part of this whole sequence, right? So, and lava magma backflowed from that area back towards the summit to feed that eruption. Which, just to point out, we're focusing on now is the difference in the earthquake patterns and the tilt patterns. So we don't see anything nearly as impressive as this today. However, it is worth noting that following that intrusion, this is now a 2-month plot from the USGS, following that intrusion in early December, I think it was 18 days later, was the beginning of the eruption on December 20th, 2020. Right? So it did indicate pressure building within the volcano that, in that case, within 2.5 weeks, led to the actual break that began the eruption and then the relieving of pressure at that point in time, with not a whole lot of clues evident in between there, right? So it could be that we're seeing just a first step towards a similar process where it does break out in the next few weeks. And this was just a first little salvo, and because of different conditions, it's not looking quite the same. That's possible for sure. Some other examples, we're going to go back to 2021. So in August 2021, that preceded the September 2021 eruption, we did have, in that case, localized to Sand Hill here in the southwest rift. That's why I want to show this here. We did have, in that case, it was an intrusionary event that had 2 pulses. Here it is in late August, I want to say the 24th, coming up, stabilizing, and then once again on a 26th, 27th, coming back up again and stabilizing once again. Right. So in that case, that intrusionary pulse of 2-phase pulse took, call it, what's that? Maybe 6 days-ish, 4, 5, 6 days, somewhere in that range. It wasn't 1 hour. It lasted a lot longer, was putting in magma for a lot longer, quaking for quite a lot longer as well. But interestingly, because that was in that southwest rift area, upper southwest rift area, if we look at the summit plot for that same time, here it is, there's the 24th. You don't see a whole lot. You just see that similar little wiggle, and not that unlike what we see today, right? So that's why it's important for us to look at other areas and other tilt meters and make sure that we're not having a similar pattern where it's not showing in a summit quite so much, because these events can be quite localized, and in that case, it's not going to show up right at the instrument that you're looking at unless the eruption is right or the intrusion is right nearby there. So in this case, quite obvious it happened in the southwest rift connector there. If I show, here is a map that I captured from that time showing seismicity. And you can see quite a bit of seismicity down here, that south part of the caldera, fanning off into that upper southwest rift connector. There's actually a USGS map that plots these as these maroon circles here, and then the purplish are the historical lava flows. So really there is that whole area of intrusion, and they've outlined in this red dashed line here what they saw from the inside, where the ground is getting uplifted, right? So kind of cracking and breaking one area, but possibly injecting into like a sheet that lifted much of that area there. So once again, a lot less earthquakes now than in 2021. But because we see this interesting dynamic between a summit tilt plot and a sandhill tilt plot, I mean, if there was an intrusion somewhere else that's not sandhill or the summit, that we don't have the tilt meter that close to, then maybe there's a signal that we're not seeing on a public-facing instruments from the USGS, right? The USGS has quite a lot more instruments they can look at internally, and we just haven't seen the actual plots, right? And it may be that they put that out, perhaps in a Volcano Watch or something when we get that updated here, and maybe they'll share more detailed plots. But as it currently stands from the public-facing data, it's not obvious that there's a tilt excursion anywhere that we can see within this last week here. There was one other follow-up to this, right? Back in 2021, I mentioned just off the plot here to the left, that was in the end of August. It took another month in that case, from the end of August to the end of September. At the end of September, we had the beginning of that eruption. Now, this is interesting as well, because unlike the previous eruption start, let me see if I can get it for you guys here. Right, this eruption start here, you see that we just essentially cracked open, relieved pressure, and just dropped down right away, right? That was the pattern here. We had the intrusion occurring earlier, right? So we have the intrusion that occurs here in late August 2021, but then coming to the end of September 2021, it looks like we possibly begin with a small intrusion as well that seems to deviate the tilt. Actually, it does reach the surface and erupts out, and that's when the signal drops entirely there, right? So it may be that if eruption had actually occurred with intrusion reaching the surface, it might have actually looked something like this, but it didn't actually do that. It just did that first little wiggle, relieved its pressure somehow, and then here we are waiting. But just to show how quickly this can happen as well, this could be what we see within the next week, or 2 weeks, or 3 weeks, or 4 weeks, or possibly longer here, depending on what the volcano does. Just to put it all out there. And then finally, end of 2022, here in September, and in hindsight, we now realize this was a response of Kilauea to Mauna Loa. Mauna Loa was filling and pressurizing, and thus putting pressure on Kilauea and pinching it in a way. So the pressure wasn't able to relieve to the surface quite as easily, and cause an intrusion underground in here late September 20th, 2022. And once again, you see another big offset here. In this case, it looks like it's about 10 microradians or so, right? And that, in that case, was not followed by another eruption. It was kind of the wind down phase. Eruption did follow eventually, obviously, in January, but in that case, it was 3 months on, right? And there was lava coming out for most of those 3 months, 2.5 of those 3 months, 2 months or so, following this event here. So all that to say that the event that we've seen here on Kilauea this past week is a lot smaller, or has a different kind of signal than we've seen in the past. No real offset there. So we could expect that there is more going on there. Not quite as big a deal as the ones we've seen in the past, but it could be significant in the fact that it's showing the lack of ability to reach the surface, right? We've been talking for the last few weeks here that magma could resume its path upwards through the conduits that already existed, and it seems like that didn't happen, right? Instead of actual pushing its pressure up out the conduit back to the surface, instead it found some other place to crack open and some small intrusion to make. And that was easier than cracking its way to the surface, right? That's the key thing there. It was easier for it to crack underground sideways than to crack up towards the surface. So as we imagine what it takes for this eruption to actually resume, will it resume, or is it actually over and is another phase, another eruption coming in the future? That's one consideration, that it does appear that this event, if anything, is giving us a little bit of insight that not so easy to come back up through the pipes that were just there, through the conduits that were there in the recently active pathways. So we'll see. We'll see. It may actually allow it to then build up more pressure. We might expect to still see more earthquakes and some following pattern, right? And that's why the USGS in their update is saying it could lead to another intrusion potentially, or another eruption eventually, or we'll wait and see. Right? And that's the story of the tilt here. And to finish off the monitoring on Kilauea, I thought we would just look at today's update here. Kilauea is still not erupting. Some eruption remains paused. Lava is no longer flowing in the crater floor. Resumption activity may occur in the near future with little or no warning. No significant changes on either of the volcano's rift zones. No low rates of ground deformation and modest rates of seismicity continue across the volcano. Otherwise, they note that there is still deflation inflation. We're in a deep portion of the DI event. Seismicity background, also to background, and that's nothing else new to report there. So that is monitoring in Kilauea, and that's as much as we can say about that intrusionary event that occurred. We can obviously discuss questions, but I thought before we did that, I would just focus on this USGS field research aspect here, where they, for the first time, went and landed back on that island in the middle. And to start us off here, let me just play the overflight video from March 10th. This was the day before the intrusion. So you can imagine actually after the fact, right? The day after they come off of this island where they're actually standing on the crater floor exposed to a potential eruption there. Then the next day they see this earthquake storm and they must have thought, oh, that might have been kind of close. Right, and perhaps that's a part of the whole story here as well. So here's the aerial view. No lava in the crater, still quite a lot of fume coming out. See they're circling around. Because of variable wind directions, they're able to get different views of the crater floor. In particular, most of the western crater floor, that's what you see here in the foreground. There's that southeast pit, that western basin right through here, the west vents off here to the left. All this clear since the wind is blowing the fume in the opposite direction than it usually does. So allowing them to really get in close and examine that basin. You see the nice little ledge drop down there. There's the west vent complex here with spatter all around. And look at that massive drop down to that moat that occurs on the outside there, right? This is the area that ooze-ups occur and lava comes in and has flooded this area in the past. So that was the video. There is a whole bunch of photographs as well. And we'll start off showing this similar capture for what you guys just saw. And in case it was moving too much, I'll just recap. North is kind of that way, I want to say. Here's that western basin. Here's that west vent complex. This is the focus of activity from 2021 to 22. But the breakout occurred east of that main island. The main island is Central Island's right in here. That breakout occurred right around through here. Eastern basins through here, and a central vent all through here. And we'll look at that coming up here as well. But first, just to show a little bit more zoomed in here, west vent complex in the foreground, west basin, southeast pit, and here in the back, this is the southeast, or that central island right through here, right? So I can zoom in a little more. But what you can see is this different color. This is more of that tephra, the bits of lava that are cooling in the air and falling down solid already, all different shapes. And at some point in time, it seems to me like, everything is changing in dimensions, right? But it seemed like this island was visible all the way to here, something like that. And in this area right through here, you see that recent eruption that kind of originated just east of there. It seems to have overlapped and covered up part of this island, right? So it really is getting smaller, and it could be that if another eruption occurs in a similar pattern, you then bury more of it over here. And at some point, you may not be able to get in there to take samples or see what's going on anymore. So the combination of lack of activity, lack of seismicity, lack of all that tilt and all of that all came the next day, allowed them to come and land on this piece of land here and drop off the scientists to collect samples, analyze, and next we'll look at what that looked like, right? So here is a view from above looking at that central island right there. Here is that vent that's right next to the island that was part of that initial outburst both in 2021 and in 2023. Over here is a central vent. That's where that big pulse came out in those last few weeks of eruption and flooded over to the east to fill that basin that way. And right in here, in orange, jumpsuits, orange flight suits, are the USGS scientists. So there is a person for scale. And since we've always been asked, like, how big are things out there? And it's always hard to judge it. We'll really point this out, because now you can see that's the size of a person right there in that orange dot, right, compared to everything else you see. And so there, compared to the size of the island, compared to the size of this southeast vent over here. And we'll get some different views here as well. So moving on to the next image. More of a low angle looking across the western basin there, right, in profile, so you can see a little bit more of the profile of that central island right there. And once again, let's zoom way in. And there, I don't know if you guys can see that. I'll overlay it. There's a person bent over, there's their torso, and there's their legs, like that. That's the person standing on that island, right? So you can estimate a little bit of how high it still remains above the rest of the crusted crater floor. And I say crusted crater floor because underneath this entire basin is all still a whole bunch of magma, right? We've been documenting and tracking that over time. Huge amount of magma. It's all just right there, and so any change could come pushing it up onto the crater floor. I would imagine that they probably considered where they could go and access, and likely anywhere on a crater floor was off limits, out of bounds. And this high ground right in here, because it is so high, it might buy you enough time if something crazy were to happen at the last minute. You could still be reasonably safe and have a chance to get pulled out of there. Still, really the scale is what I'm finding most fascinating about this. And so let's show the next picture. All right, a little bit easier to see the people, maybe. Right there, a couple of scientists in the jumpsuits. All right, on the flank of that remaining island. That's this light brown area here. And you see one part of it is actually exposed and showing quite a bit of oxidized rock here, that orange reddish color, right? The rocks have quite a bit of iron in them, 10-11% more or less, right? So when you expose them to heat and especially moisture, they'll essentially rust as oxidizing. So it's like a similar process to rusting. And that's that color exposed right through there. And from the ground level, here's one of the scientists photographing the other from standing on the island itself. And so there it is. There's the person. I believe it's photographed by Drew Downs. Can't quite recognize who that is across the way there. But maybe we'll get a clue here. And you can see that there's a lot of this brownish kind of spatter, making quite a bit up the substrate of this island. But there's also this more intact, slabby Pahoehoe lava that's on here as well, right? Because this island's been covered by multiple phases, and we'll see some of that pulled out here as well. So, starting with the image of the tephra, here is a close-up they took of that steaming, fuming area that's oxidized. Here it is. The island's a composite of red, yellow oxidized pieces that range from sand size up to a few feet, or about a meter in diameter. And that's what you see there. Here's a zoomed in close-up, right, with a Sharpie for scale, showing the different sizes of blocks that are in here and their angularity. You see a lot of stuff is really, really angular. And not well sorted here, all different sizes all across. But as we imagine, this is the stuff that was formed during that very first phase of the 2020 eruption, December 2020, when lava evaporated, vaporized that entire pond of water that had been building in the 2018 collapse pit for the previous year, and vaporized it all within 60, 90 minutes or so. Likely produced some frothy rock that had some gas trapped in it, or was slightly less dense in some way. That's what essentially is making the core of that island, which is why that island actually was an island. It floated up, spun around, moved all over the place, and eventually got locked in place into the crater crust. And now it's being covered by successive overlaps, right? And the more stuff we pile onto it, we're changing the density of the whole thing, and eventually we'll actually be able to bury it. So, since it's always been a question, why is that thing even floating? One obvious way to try to figure that out is to actually come onto this place, onto this site, and see what you can discover. Not just visually like this, but I'm sure samples were collected, and they can then do analysis on them to see what kind of chemical reactions are occurring and all those kind of interesting things as well. So that's the close-up of the tephra. And one last view of the tephra here, just looking at the difference in the browner 2020 material from the 2021-23 material. You can see there's more coherent slabs of Pahoehoe lava here, and the fountain was shooting up and then landing, splashing on the side of this island before it floated back on the crater floor. And so that's the last on-the-ground image there from the scientists. So pretty cool that they were able to land on there. They did take a few other pictures that we'll share here real quick to kind of put things in perspective. Here is that western crater floor area, which is not often visible because of fume. So west vent over here, and that's that western basin, southeast pit over here. And once again, west vent complex from above, showing different kind of textures. You see more of that reddish texture from that original spatter getting baked by the continual steaming that's coming out of here. You see the ooze up very smooth Pahoehoe lava flows here on the side. And you also see this apron of darker powdery material over here as well. This little apron that's likely more recent tephra that's being shot out of the steam hole as well, right? It can shut out, so it's younger, hasn't been oxidized quite yet, and it's overlapping all the other lavas you see here in the foreground. Here's a caption. The aerial view of the western vent shows the red oxidized interior walls of the ramparts with several steaming areas. The outside southeastern side of the rampart and nearby crater floor is covered by a black apron of dust, possibly created by little tephra bits flying out of the now steaming vent in the rampart wall. So nice caption there, good illustration. So there is that western basin once again, the southeast pit right here. So we're kind of looking, I think this is kind of a little bit more to the north here, so you can see the different levels of sagging of that crater floor. It looks like there's a lower sagging here, and then there's a little bit of an upper right through here, right? So this was the area that was feeding inwards, that after it hardened, we saw the inner part overturning and repaving itself, and likely it lost some gas volume through that, and that's why you see this little drop in level from one place to the other. Over to the east, there's that central island once again right through there. Central vent right through here, and here's that eastern lava basin that was filled with lava until fairly recently, about a month ago. And all drained now, but showing all the complexity of what we saw before, where little islets, all these little bits were sticking up in little islets, and then we also saw this big peninsula-like feature here get torn from the wall here and rotate across before it got parked and frozen in place right there. So interesting to note all those features on there, and we probably can do a much deeper analysis of all this, but in the interest of time and not bore anyone, we'll just keep moving on and leave that for anyone who wants to explore that further on their own. So a couple of last ones here. This is the last photograph of that southeast pit itself. There is some kind of tube that comes in from that main western basin all through here. We saw that tube forming back last year before that as well. and feeding this pond, which at times has spattered and made spatter features on a rim, but also has formed perch ponds in those dying phases. You see that kind of circular feature right through there as well within that eastern pit. So more looking at the cool features as they sit now, but as I said, I won't go into any more detail than that here. A couple final things are the thermal maps that were produced this past week. We don't quite have an eruption volume map. Hopefully that'll come out here in the next week. That usually follows the overflights and the thermal maps. So not quite yet, but hopefully next week. And so this is a thermal image showing what areas remain hot still, and it's just in that western basin. You see a little bit across that western basin, but more so this was that little patch that overturned, the last patch that overturned, as visible on camera there at the end of last week. So that's the zoomed in view, and that the zoomed out view showing which area is the crusted lava lake compared to the rest of the collapse zone from 2018. All right, so that's the research photographs we have for this week. And one last thing before we get into questions and discussion here will be Mauna Loa. Just recapping once again the switch in activity level from advisory yellow to normal green. And the summary is there's not really anything new here. Inflation continues. What I read last week, what was expected, you'd expect increase in seismicity, increase in tilt variations and all that preceding eruption. What we're seeing now is that recharge of the volcano following eruption, which is kind of typical to what we saw post-1984 and post-1975 as well. So just to show it though, here's a tilt for the last week. It's still rising in this kind of slow rate here. Here it is for the last month. This slow rise may be a real signal potentially, just showing that recharge into the shallow areas a little bit. Nothing alarming, nothing climbing super fast. Not that we would see that necessarily in Mauna Loa. It's really the earthquakes that give it away in Mauna Loa. GPS has not been updating still, so we can't really show more of what's happening recently, but the pattern likely is still the same. It's likely still going up and recovering. And at some point, you'd imagine it might do the plateau and then go up and plateau and go up, and that kind of thing as it adjusts. But we can't see any of that evidenced yet. It's similar for the up signal here. That's what we have in Mauna Loa. Earthquakes pretty much non-existent in the summit area. A couple of those flank ones adjusting. That's all normal. The last thing in Mauna Loa is a recovery point right here. This is from the Keeling Curve blog from UCSD, University of California, San Diego. That's looks like written by Ralph Keeling here, right? The originator of the Keeling Curve, measuring CO2 in the atmosphere, as well as detected the ozone hole in this area here, right? So in this case, they are happy to report measurements by the Scripps CO2 program resumed at Mauna Loa Observatory on March 9th. So just 1 week ago. The CO2 analyzer is being powered with a solar power battery system installed by NOAA staff at the observatory using helicopter access. The resumption ends a gap in measurements which began November 28th when a lava flow from eruption of Mauna Loa buried the road and cut the power line to the station. There's a helicopter dropping a sling load of batteries and other really heavy stuff. The road is still cut off, right? There wasn't a huge impact of the Mauna Loa eruption on infrastructure. What it did cut off was the Mauna Loa Observatory Road. So this was the primary impact, and it's kind of niche, but for atmospheric scientists, this is a super, super important site. And you can see how much effort they're putting into getting it back online. It is back online now. However, they also report an analyzer at nearby Mauna Kea, which was installed December 14th as a temporary alternative to the Mauna Loa measurements, stopped sending data on March 7th. The cause of interruption is unclear. They're working with staff to diagnose the problem. And that's the end of that, right? So ended up with just a 2-day gap between March 7th and March 9th, and thankfully everything's resumed there for atmospheric science data collection. So quick recovery point on Mauna Loa here. And that is it for the volcanoes. There's a couple community events to mention real quick. One is this upcoming talk at Kahuku this coming Saturday, 9:30 a.m. to 11 a.m. Park Ranger and Kau resident Jay Robinson is going to describe the hand-to-hand combat and the Battle of the Bitter Rain, and the battle is still in canon. 2 battles between the cousins Kamehameha and Keoa Kua'u'ula. that were brutal, and I still think that the stories I've heard from Jay in the past about all the different battles on Kilauea could make a great HBO miniseries one day. If anyone writes for HBO, give us a call. But like really, the story is pretty amazing. Some really fascinating stuff in there. So hopefully we'll have a chance to record that and at some point share that with you guys, but we'll have to wait and see about that too. So that's the only event here on the schedule for the rest of March on the park calendar. However, as we mentioned earlier, we did attend the open house at the USGS last night as part of the public input process to the environmental assessment of the proposed facility in Hilo, not far from Loa. Public input is still open through email through March 28th. So you can see the draft environmental assessment. There's a link to it on the USGS site here. Otherwise, you can still send emails about the proposed sites, and the way it goes is comments to these email addresses here, right? So better to look at the USGS news page and pull the links directly there. So, but that's what we have ongoing in the community here. All right, Dane. I'll pass it to you.
Right. Yeah. And I think we talked about it last week, the environmental assessment and everything that was going on up there in that new facility. Seems like the takeaway that I saw was that they're trying to reach the sustainability by 2030. So a lot of solar panels, a lot of photovoltaic action going on up there. It's a pretty sophisticated facility. But yeah. We do got a couple. Oh, go ahead.
Yeah, net zero. Yeah. So yeah, solar panels all over the place. Room for a PV installation on the ground. Yeah, so they're really trying. Yeah. Construction of all local materials, all the usual stuff. Architecture that fits this area, et cetera, et cetera.
Yeah, it's a good place for it too, up on the hill there. All right, so I want to acknowledge everybody that tuned in today. Without the volcanoes doing much, usually we don't get all that many viewers coming in. So the likes, the shares, people stick around. That really does help, and we appreciate you. We did have a couple super chats come through. Want to thank them. We had a returning supporter, Chris Kiki, with the $20. Just says you're amazing. Appreciate the support there. We also had a 1999 super chat come through from L. Lawler. Thank you, guys. I appreciate all the support there. And we do have a couple questions, but first I want to acknowledge, County of Hawaii. They, help support this program and the content that we're able to produce on Hawaii Tracker. So really appreciate the county and the VIVI grant program, Grant Aid, for helping us with this whole endeavor. All right, I think we can get into a little bit of the questions here. We don't have all that many, but some earthquake questions going on. First one was about the 50-mile deep earthquake off of South Point that happened in the past week. I don't know what day exactly, but a deep old one somewhere near the volcano formerly known as Loihi. And just they wanted to see your thoughts on that, because that is a deep one for us. Yeah,
that's really deep, right? Like 50 miles deep, 50 miles away from the volcano. Really, right? So it's like a whole different place than the volcano is. It's certainly near the roots, but the actual feeder zone there, you imagine, comes more from that Pahala region where all the earthquakes are actually happening, right? So more than likely, that's just some adjustment of the crust to all the mess that's happening here on Hawaii Island. That's, we're talking about Kilauea moving, Mauna Loa moving. We haven't talked about Loihi moving because there's no instruments on a flank because it's underwater, right? But it all moves, right? And everything around it has to adjust, right? Sometimes I have used an analogy of the whole crust that everything is riding on is like a big waterbed, right? And so we have someone like Hawaii Island's lying on a bed, and it's like creating this divot around itself because it's weighing it down so much right there. Right? But really, it's not the island. It's really like you really have different parts of it. You have Mauna Loa and Kilauea and everything else. So let's say Mauna Loa moves a little bit and Kilauea moves a little bit. Then you might cause a ripple effect outwards a little bit where the outer parts have to adjust to that redistribution of mass and balance and all that. So oversimplifying it, I'm sure, but that's one way I think of it. 50 miles down, though, that's like actually below that whole crustal region. It's more like in the mantle, right? So it's really fascinating. To have an earthquake, you really have to have rock that's solid enough to break, right, or actually change in volume somehow, right? some people have proposed in the past you can have mineral transitions where the minerals can actually be very deep down and change your crystal structure, right, from something that's less pressure resistant to more pressure resistant, right? Similar to like everyone's heard about diamonds are formed at a really high pressure, right? And diamonds are pure carbon. So is graphite, right? And if you take graphite and put it deep enough, it'll reconfigure into a diamond crystal structure, right? But it's got to be really under a whole lot of pressure. All minerals do that. Olivine does that, like different depths, right? So you could actually have some change in volumes through that, and usually that's thought of as deeper earthquakes than that. So if you see something that's down at over 100 miles, 200 miles, that's usually that kind of thing that's brought in, that's invoked, right? So that's kind of in the field of play, but you also could have these pathways where you have the mantle flowing as a fluid on this kind of 1 inch, 2 inches, 4 inches a year time scale, but other energy coming through there that actually causes it to snap and deform in more elastic, brittle ways that's coming through faster. I'm not sure I explained it very well, right? But the mantle is weird because it behaves in both as a solid and as a liquid. Best analogy might be like a silly putty.
It's like that non-Newtonian fluid that where you it's the fluid, but then you push on it, all of a sudden it becomes a solid, kind of like that.
Yeah, it's about the rates, right? So like silly putty, right? If you take silly putty and you pull it slowly, you'll see it stretch and stretch and stretch, and eventually it'll just like separate, right? It's moving like a fluid. It's kind of just flowing, right? You take that same silly putty and you pull it really fast, you'll snap it and it'll break because of the different rate of force there, right? So it can, depending on how you're applying the pressure and then what the properties are of that material, it can behave both as a fluid or as a solid, right? That's kind of the easiest way to explain it without getting into the physics of it to people who may not have that background. So long story short, I mean, I'm not sure what that earthquake was 50 miles down, but those are some of the ideas. It could be settling of the island, around the island. It could be adjustment of these magmatic pathways to some of the rocks that are down there. It could be some crystal rearrangement of the structure. I mean, I don't know. That's the bottom line. I don't know, but those are the things that we can discuss as possibilities there.
Right. When I first heard it, I thought somebody said 50 kilometers. I was like, oh yeah, it's just a deep Hollow, a little deeper than Deep Hollow, and then it's 50 miles. It's like, oh, well then. All right. Well, we did have a $10 super chat come in through from JW. Appreciate that. No comment on that one. And we have a question from Bill that I liked. It says, does an intrusion have to be towards the surface from a shallow reservoir, or are there deeper, perhaps lateral movements of magma also called an intrusion?
Yeah, absolutely. It can. I think it's just as likely that it goes sideways, right? Because you have to imagine where the weaknesses actually are, and the way the lava flows stack on each other, they come in layers, and so often you have planar breaks between those layers, and so those are zones of weakness, right? So when you inject a lava flow, it's harder to push it up through all that stuff than to push it into a zone of weakness already. So I think it's quite likely, and I think some of the results that we've seen, especially all the ones that have offset, right? We're seeing a vertical offset on those tilt meters. It's likely something that's injecting in some kind of sub-horizontal manner, and then popping something up to actually cause an offset. So one thing I didn't mention with our signal now is if we had an intrusion that was more vertical, you might not get that vertical offset, right? It might actually just be more of just a little wiggle. But what really separates it is the lack of earthquakes, right? And I had to really look at that USGS plot to show the earthquakes to the greatest detail possible, whereas this map here doesn't really show nearly as many of those earthquakes. Still shows quite a bit, but it doesn't show that detail we saw on that last plot. So yeah, absolutely. It absolutely can be in any direction, right? Whatever the crack happens to be, if it happens to be, flat cracks, we know there are plenty of them, right? Collapse cracks from the 2018 collapse, we know that they exist as well. They're maybe not exactly vertical, they might be more inclined. So that's also fair game, right? And yeah, absolutely. All those possibilities. You can get technical and call one if it's subvertical, you call it a dike, and if it's subhorizontal, you'd call it a sill. But that's just terminology. And
would on that point, does the sill have to be where it doesn't break the rock, right? Where it goes in and doesn't break the rock that existed before? type of thing, or can it do that and still be considered a sill?
Yeah, I think it's the same kind of thing. It can break the rock. I mean,
Okay.
if there's a void there, then absolutely it's going to find a way. It would use the void. But it can also like just be like a wedge, just like driving a wedge in between two layers and just wedging them apart, right? And actually forcing its way into that weakness. Yeah, there's an old kind of another term, laccolith, right? It's like a big fat sill. Like after they crack their way in, it can actually be a little magma pocket and can keep being fed, and it can kind of swell, bulge, almost like a pimple kind of thing. There's one on a north wall of Kilauea caldera that was easier to see before the whole collapse feature. Now there's more kind of rubble all around it, but maybe we can find some images of that sometime and pull it out and look at what that looks like and help people imagine what that might look like underground. But yeah, that's a good example for sure.
Right. Chris asks, is the USGS going to start assigning letters to the summit eruptions like they did with Pu'uo'o ones? It appears to be pausing like the Pu'uo'o ones were. So I think this is like the episodes, right?
Yeah, episodes. Yeah, they did use episodes for Pu'uo'o. That's a good question.
I've actually talked with Ken about this, Ken Hahn from USGS, and he was saying that right now they're considered separate eruptions, right? But when people start looking back at these eruptions after a little time passes, he thinks that they would be put into episodes of the same eruption, right? Once a little bit of time passes, you get out outside of the trees, right, and you can see the forest, they'll be put into the same type of category. So, yeah, that's a great question there, Chris.
Yeah. So yeah, that may likely happen. It hasn't happened yet, but yeah, as Dane says, as Ken said, it might take a little bit more time to really see the big picture there. But we've really considered it all one big phase of summit return of activity, right? And the bottom line is, those are all just human definitions, and the bottom line is magma's coming to the volcano ever since the 2018 collapse and refilling the collapse zone and finding its way to the surface one way or another, however it can, and whether we choose to divide it into episodes or different eruptions or different phases, that's all on us. It's basically on is the bottom line for Kilauea. Kilauea is on underground and building underground, erupting.
Just a matter of time.
Yeah.
It's back again. And we'll be having some fountains or something like that, and maybe go live with those, but we'll see when that happens. It was interesting to see the alert notice or the volcano notice about the intrusion, which was at the time thought it was going to be very likely to erupt, right? The wording that was chosen was it looked like it was going, but then as soon as you say something about Kilauea, right, you're like, I think I know what it's about to do. It just changes up on you, type of thing, and that's kind of what happened. And within an hour of that post being released by USGS, it was like, well, the tilt's quiet and the seismic's quiet, right? It's like that changed quickly. Right there.
Yeah. And I think there definitely were, once the swarm started, and we saw how quickly Mauna Loa went, and they're trying to trying to
play that game.
Yeah, all the alerts as possible, right? So they're trying to do more of them, which means you're going to have more of these false starts too, right? So it's great to see them actually putting it out. Events like this in the past have not had alerts put out for them because not enough earthquakes and not enough tilt. Bottom line. Really, when it comes down to it, I looked at I saw a significant tilt excursion. I was like, really? I don't see it. Maybe it's not public facing, right? Like I mentioned earlier, that we actually can't see it. Certainly the tilt was wiggling in funny ways, but not very much, right? Fractions of a microradian, and ended up back at the same place. The biggest
it does that for various reasons.
Yeah, and the biggest tilt offset was the actual earthquake shaking it. So
right.
So there's overlapping data there too, right? So that can be tricky, but yeah, we'll have to wait and see there.
Yeah, good question. It's only a matter of time. That's all. It's so active that we're just talking, weeks to months type of thing, right? And in geologic time, that's nothing, right? It's just a blink of the eye. So. Right, we're just making these delineations because it's convenient for us to talk about in real time, living it type of thing.
Yeah, exactly. Yeah. It's just taking a breath.
Right. All right. Well, I think that gets us through the questions. I'm sorry if I missed any. Appreciate everybody that tuned in today. We went over our hour, as usual. And we will be back next week unless something happens. You know, maybe we'll go live and cover that. But you know, got to be doing something. If not, next Thursday, 5 p.m., we will be live again with at our normal time to do another recap and talk about the latest.
Yeah, and maybe if nothing does happen, maybe we'll actually eventually have a short update, right? I haven't done it yet. I didn't even try to claim that today. I knew we were gonna have to talk about context, and once I saw all those images of helicopter landing on an island, that was pretty cool. So maybe we'll get more of that sneaking out here in a bit. And
yeah, hopefully we'll get a video of that whole thing. That'd be I'd like to see. You know, like they're just their foray into the volcano on the chopper.
yeah, maybe, yeah. We'll see.
All right. Well, thanks, Phil.
Thank you, Dane. Thanks everyone for watching. Thanks for you guys who contributed. Thanks for tuning in. Like, share, and subscribe as usual. Until next week, from HawaiiTracker.com, he's Dane DuPont. I'm Philip Ong.